The allowable voltage on a 120 volt outlet is 120 volts plus or minus 5%. This means the voltage should ideally be between 114 volts and 126 volts. A voltage measurement of 125.2 volts falls within this acceptable range according to standard electrical guidelines. However, it is important to understand that even though the voltage is within the acceptable range, some sensitive electronic devices and appliances may exhibit unusual behavior or even shut down if the voltage deviates from the ideal 120 volt level. The sensitivity of electronic equipment to voltage variations is a design characteristic and can vary significantly from one device to another. Some devices are built with robust power supplies that can tolerate a wide range of input voltages, while others are more sensitive and may be affected by even small voltage fluctuations. When a device shuts down or trips at 125.2 volts, it indicates that the device's internal circuitry is not designed to handle voltages at the higher end of the acceptable range. This can be due to several factors, including the quality of the components used in the device's power supply, the design of the voltage regulation circuitry, and the device's overall power consumption characteristics. Arc fault circuit interrupters, RFCs, are designed to protect against electrical fires caused by arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. RFCs constantly monitor the electrical current flowing through a circuit and look for telltale signs of arc faults, such as sudden changes in current or the presence of high-frequency noise. When an RFC detects an arc fault, it quickly trips the circuit, cutting off the flow of electricity and preventing a potential fire. It is somewhat unusual for a slightly elevated voltage of 125.2 volts to directly cause an RFC to trip. RFCs are primarily designed to detect arc faults, not over-voltage conditions. However, there are a few possible explanations for why your RFC might have tripped in response to the elevated voltage. Firstly, a pre-existing condition could exist in the wiring. There might be a loose connection, damaged insulation, or some other wiring issue that is already creating a marginal condition. The slightly elevated voltage could exacerbate this condition, causing an arc fault to occur and triggering the RFC. Secondly, the RFC could be hypersensitive. Although RFCs are designed to meet certain performance standards, there can be some variation in sensitivity from one unit to another. It is possible that your RFC is more sensitive than average and is tripping in response to even minor voltage fluctuations or electrical noise. Thirdly, there could be a faulty RFC. Like any electronic device, RFCs can fail. A faulty RFC might trip randomly or in response to conditions that would not normally cause it to trip. If you suspect that your RFC is faulty, it should be replaced by a qualified electrician. It's important to investigate the underlying cause of the elevated voltage. While 125.2 volts is within the acceptable range, it's still higher than the nominal 120 volts. Finding the source of the elevated voltage can help prevent future problems and ensure the safe operation of your electrical system. Several factors can cause voltage to be higher than normal. Firstly, there can be issues with the utility company's voltage regulation equipment. The utility company is responsible for maintaining the voltage within a certain range, but sometimes their equipment can malfunction or be improperly adjusted, resulting in higher than normal voltages. Secondly, there could be a problem with the transformer serving your home. The transformer steps down the high voltage from the utility lines to the lower voltage used in your home. If the transformer is not functioning properly, it could be delivering a higher than normal voltage. Thirdly, there could be a neutral wiring issue. A poor or loose neutral connection can cause voltage imbalances and elevated voltages on some circuits. This is a common problem that can be difficult to diagnose. If you are concerned about the voltage in your home, it is recommended to have a qualified electrician inspect the electrical system. An electrician can use specialized equipment to measure the voltage at various points in the system and identify any potential problems. They can also perform a thorough inspection of the wiring, outlets, and circuit breakers to ensure that everything is in good working order. An electrician can also check the grounding system to ensure that it is properly installed and functioning correctly. A properly grounded electrical system is essential for safety and helps to prevent electrical shocks and fires. During an electrical inspection, the electrician will typically perform several tests to assess the health of the electrical system. Firstly, they will measure the voltage at the main service panel and at various outlets throughout the home to check for voltage drops or imbalances. Secondly, they will inspect the wiring for any signs of damage, such as frayed insulation or loose connections. Thirdly, they will test the circuit breakers to ensure that they are functioning properly and are not overloaded. Fourthly, they will check the grounding system to ensure that it is properly installed and connected. If the electrician finds any problems during the inspection, they will recommend the appropriate repairs or adjustments. These might include tightening loose connections, replacing damaged wiring, upgrading the circuit breakers, or improving the grounding system. Addressing electrical issues promptly is important for safety and can help to prevent more serious problems in the future. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform any electrical work. Working with electricity can be dangerous, and it is important to take proper precautions to avoid electrical shock or fire. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. If you are unsure about any aspect of electrical work, consult a qualified electrician. It is also worth noting that the National Electrical Code, or NEC, provides guidelines for acceptable voltage ranges and wiring practices. The NEC is a set of standards that are widely adopted in the United States and other countries to ensure the safe installation and operation of electrical systems. The NEC specifies that the nominal voltage for a 120-volt system is 120 volts, but it also allows for some variation in voltage due to factors such as load changes and voltage drops. The NEC also provides guidelines for the size and type of wiring that should be used for different circuits, as well as the proper grounding and bonding techniques. Following the NEC guidelines is essential for ensuring the safety and reliability of electrical systems. It is important to keep in mind that electrical codes and regulations can vary from one jurisdiction to another. It is always a good idea to check with your local building department or electrical inspector to determine the specific requirements in your area. They can provide guidance on the applicable codes and regulations and can answer any questions you may have about electrical safety. In addition to the NEC, there are other organizations that provide standards and guidelines for electrical safety, such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These organizations develop standards for electrical equipment, wiring practices, and safety procedures. Following these standards can help to ensure that electrical systems are designed and installed safely and reliably. When troubleshooting electrical problems, it is important to use a systematic approach. Start by gathering as much information as possible about the problem, such as when it occurs, what devices are affected, and any recent changes that have been made to the electrical system. Then, use a process of elimination to narrow down the possible causes. Check the circuit breakers, outlets, and wiring for any signs of damage or loose connections. Use a multimeter to measure the voltage and current at various points in the circuit. If you are not able to identify the problem yourself, call a qualified electrician. They have the training, experience, and equipment to diagnose and repair electrical problems safely and efficiently. When working with electricity, safety should always be your top priority. Electricity can be dangerous, and it is important to take proper precautions to avoid electrical shock or fire. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. If you are unsure about any aspect of electrical work, consult a qualified electrician. Remember, even though 125.2 volts is within the acceptable range for a 120-volt outlet, it is still important to investigate why your shortest device shut down and why the SI tripped. These events could be indicative of underlying electrical problems that need to be addressed. A qualified electrician can help you diagnose and resolve these issues to ensure the safety and reliability of your electrical system. Understanding the allowable voltage range for 120-volt outlets is crucial for maintaining a safe and functional electrical system. While a voltage of 125.2 volts falls within the acceptable range of 114 to 126 volts, it's essential to consider that sensitive electronic devices may react adversely to voltages at the higher end of this spectrum. This sensitivity can stem from the design and components of the device's power supply. Moreover, the tripping of an off-site, while not directly triggered by overvoltage, could point to underlying wiring issues exacerbated by the slightly elevated voltage. Therefore, it's recommended to have a qualified electrician inspect the electrical system to identify and address any potential problems, ensuring both safety and optimal performance of your electrical devices. Remember, regular electrical inspections and prompt repairs are key to preventing electrical hazards and maintaining a reliable power supply in your home.